Hello dear students, welcome to Unacademy, India's largest learning platform. So let me introduce myself. Okay, myself Sunil Manjani. I've got around 15 plus years of teaching experience. Okay, and myself have cleared okay. So, 15 plus years of teaching experience. Okay, mentored thousands of students for GATE ESE semester exam, cracked PSU exams like GATE, HAL, MAR, DISCOM, MAR, etc. Okay. So let us see how to use Unacademy. Go to Unacademy Learning app, install this app. Okay. So in step 3, go to manage goals after permission and registration. Okay. Go to GATE and ESE, click on plus subscription. Okay. You will be prompted to click on get subscription button. Okay. So there is plus subscription. Okay. This is 1 month, 3 months, 6 months, 12 months, 18 months, 24 months. Okay. So this 24 months, sorry, 12-month package is of 27 to 20 to 27. Okay, and 18-month package is of 34,650. 24-month package is of 39,600. Okay, you can select iconic subscription where 12-month package will cost you 45,225. 24-month package will cost you 66,600. Okay, SSM10 is my code. You can use for further 10% discount. Okay, so what do you get in plus subscription? Okay, see, India's best educator teaches you interactive live classes, structured courses in PDF, live test and quizzes. Okay, for iconic subscription you get all the features of plus subscription plus personal coach, personalized test analysis, study planner, proprietary study material, etc. Okay, so today we are going to uh, go with MATLAB fundamentals. Okay, so today's session will cover Today's session will cover state space analysis, or you can say approach in control system. Control. Okay. So you can see that, okay, in today's session, okay, so what is state space approach? State space approach. Okay, so in a control system we have seen this is input signal, okay, this is plant gain, this is output signal. Okay, so in regular approach we are concerned with input and output only. Input and output only. So input and output only. Okay, so in state space we are concerned with input, output and condition of various measurable parameters. Various measurable parameters. Condition of various measurable parameters. So let us see that what are these various measurable parameters. So various measurable parameters apart from the apart from input and output, input and output apart from input and output, okay, are called states, which are internal state. Okay, for example, I will consider one electric circuit. Okay, so this is one electric circuit I am considering. This is one electric circuit I am considering. This is R1, R2, R3, R4, etc. Okay. Let us say that this is current II, this is current I0, voltage VI, voltage V0. This is current I1, I2, this is I3. Okay, so these are the states. These are the states. Now, what will happen that? Okay, now what will happen that I will call VI, II, V0, I0. This I will call as input states. This I will call as output states. Output states. Okay, so these are available outside the circuit, that means outer part of the circuit. So these are called as external states. These are called as external states. Okay, now let us consider input current current I1, I2, I3. Okay, current I1, I2, I3. Let us say that this voltage is Vx. Okay, this voltage is Vx. So let us consider Vx. Let us consider Vx. Okay, all these are present in the circuit except output and input. So these are called as internal states. Remember, we said that these are measurable parameters. So we can measure I1, I2, I3 and voltage at the terminal X, that is Vx. These are also measurable parameters. These are internal states and external. Okay. So I got input. Okay. I have got output. Okay. I have got internal states. These three are the parameters in state space solution or approach. So input is usually denoted by a signal. Suppose we are saying step signal. This is input denoted by U. Output is denoted by Y and internal states are denoted by X. Internal states are denoted by X. Okay. So if I want to write down equations in state space approach, Okay, what these equations will be? First equation is state equation. Okay, I will write down state equation is derivative of state is equal to ax plus b u. This is in matrix form. Okay, general form. General form general form is x dot is equal to ax plus bu. Ax plus bu. Okay, where A is called as system matrix. Okay, B is called as input matrix. Okay, input matrix. Okay, so when I say this x dot, this is x dot. Okay, this is input matrix, this is output matrix. What is size of x dot? What is size of x dot? Let us see. Size of x dot is n into 1. Size of A is n into n. Size of x is n into 1. Size of B is n into n. Okay. And size of U matrix is equal to m into 1. M into 1. Okay. Where m is equal to number of inputs, n is equal to number of states. Number of states. Okay. So this is the meaning. What I will say, I will define what is x. X is a state matrix. U is input vector. This state matrix or state vector, you can say also, it is same thing. Okay, x dot is nothing but derivative of state. Okay, x dot you can denote it as dx divided by dt. So this is state equation. This is state equation. Okay, so now output equation. Output equation. Okay, let us say that this is second one. Y is equal to C x plus D U. Okay, where you can say that size of Y matrix is P by 1, size of P matrix C matrix is P into N, size of Nx matrix is N into 1, size of D matrix is P by M, size of U matrix is M by 1. Okay, M by 1, where P equal to number of outputs required, number of outputs required. Okay, so this is P matrix. Okay, now we'll see what is Y. Y is output vector, C is output matrix, X is state matrix, D is input output coupling matrix, coupling matrix. Okay, U is input vector. Okay, so in general form, Y is equal to Cx plus du. Cx plus du. Okay, these two definitions are applicable only to multiple input and multiple output system, that is MIMO system. Okay, so how it will be MIMO system? Input R1, R2, Rn, output y1, y2, yn. This is MIMO system. Okay, so for single input, single output system, okay, that is TISO system, this will be like this, R, this is Y, R and Y. So this is TISO system. Okay, so for TISO system, state equation and output equation is x dot is equals to ax plus bu and y is equal to cx. Okay, y is equal to cx. Okay, now we'll draw block diagram of a MIMO system. So equations are x dot equal to ax plus bu, y is equal to cx plus du. Okay, so simple measure is here. I have got input u and I have got output y. Okay, see here, from here, if I multiply u with b, I will get bu. Okay, if I multiply d with u, this bu is associated with x dot. Okay, if I multiply d with u, this is u, I will multiply it with d, so I will get something associated with the system, output system. This is output. Okay, let us say that this is x, internal state x. If I multiply c with x, what I will get? Cx. I will get cx. If I multiply d with u, what I am getting? Is du. Both these two I can add together to get y. Both these two I will add together to get y. So I will add together these two signals, positive and again positive, I will get y. So this equation is taken care of. Okay, now see here, what is the relation between x dot and x? x dot is equal to derivative of x. So if I integrate both sides, what I will get is okay. So again we will see x dot equal to dx by dt. So x dot dt equal to dx. Integrate x dot dt is x. This is integral dx. So I will say that if x dot is integral of x dot is derivative of xt, then I will say that x is integral of dx. What is dx? X dot. Integral of x dot. Okay. So here is x. Here is x. So I will say this is integral of what? Integral of what? X dot. X dot. This is integral sign. We will give you x. Okay. Now b I have multiplied with you. B I have multiplied with you. Okay. Okay. This is x. This is x. So if I add a to this, I will get ax. This is ax. This is bu. Ax and bu. I will add these together. Okay. I will add these together. This is ax. This is bu. I will get x dot. I will get x dot. Okay. So this is the block diagram of MIMO system. Similarly, you can draw block diagram of ESO system. What is the equation? X dot is equal to ax plus bu. Y is equal to cx. So I have got y. I have got u. Multiply u with b. I will get bu. I will get bu. Okay. Multiply c with x. I will get y. So let us suppose this is x. This multiply c with x. Cx, that is equal to y, isn't it? So this is x. Multiply x with a. I will get ax. I will get ax. This is integral. And this is x dot. Okay. So these two I will add, plus and plus. So this is ax. This is bu. Ax plus bu is equal to x dot. And x dot integral is equal to x. X into c is cx. This is so. This is block diagram of which system? MIMO system. Okay. Sorry, CISO system. Sorry, CISO system. Okay. So this is the way I can find out block diagram. Okay, so I will consider a circuit switch mode power supply circuit, in which what I will do is I will take an input plus minus VD. Okay, I will take a diode connected, output of diode transistor is connected with diode. Okay, this is output circuit. This input circuit is connected to some controller. Okay, this is equal to some reference value. Okay, this is smoothing inductor, a capacitor. This is output resistor RL or load resistor. This is output. This is the signal for comparison output. Smoothing reactor current is IL. So this is the definition of controller. Okay, definition of controller. Okay, so let us see equivalent circuit of this. Okay, so this is VD plus minus. Okay, this transistor and diode will behave as a switch, double throw switch. This is A, this is VI. Okay, this is resistor R, this is inductor L, capacitor, and then load resistor RLC. This is current IL. This is V0. Okay, VC. This is point B, point C, point. This is equivalent circuit of the above circuit. This is like the circuit VI, or simply some VI. So how would be VI? Let us see. This is VI. Okay, this is T, this is T on, this is T off. Okay, so this is VI. So this is VI, isn't it? So what we are doing, we are actually developing a state space equations. We are developing state space equations. This is S1, this is S2. Okay. Okay. So when switch is at S2, switch is at S2. Okay, or rather S1. So what will be the position? This is VD. Okay, this is switch A, this is S1, resistor, okay, inductor. Okay, earlier inductor was in steady state. So in steady state, what will happen? Inductor will behave as a closed switch or short circuited in steady state. Capacitor will behave as a open circuited. Capacitor will behave as a open circuit. So let me redraw it once again. Okay, just a minute. This will be the state of equation. This will be short circuit inductor and open circuit capacitor. This will be inductor current IL. This is R. So IL 0 minus is equal to VD upon R plus RL. V, so which implies IL 0 plus is also equal to VD upon R plus RL. Therefore, output V0 plus is equal to IL 0 plus into RL is equal to VD upon R plus RL into RL. So this is the equation. This is IL 0 plus. Okay, let us say switch is at S2. This S2. Okay, so this will be like this. This is Vi, this is S2, this is R. Inductor will behave as a constant voltage source. Suppose this is IL. Okay, What about capacitor? Capacitor will behave as a constant voltage source V0. Okay, if you go back one slide, if this is V0, this is Vc, I will say V0 is equal to Vc. So Vc0 plus is equal to V0 0 plus, that is equal to VDRL upon R plus RL. So capacitor will behave as a constant voltage source. Okay, and this will be RL. So this is Vc, this is V0. Okay, so now I will apply KVL to this part of the circuit. KVL to loop 1. So Vi minus RIL. Okay, this is plus minus Vc, minus Vc, minus Vc. If this is the inductor, okay, this is at 0 plus circuit, 0 plus Vc 0 plus is equal to 0. Okay, let us say circuit at t greater 0, that means switch is at S2. Vi, this is S2, R, L, C, RL. This is V0, this is Vc. Okay, so if I apply KVL to this internal loop, this will be current IL. So if I apply KVL, I will get Vi, this is Vi, minus RIL minus LDIL by dt plus minus Vc equal to 0, so that I will get, this was point B, okay, Vi, okay, or rather I will say RIL plus LDIL by dt plus Vc is equal to Vi, okay, let this be equation 1. Okay, now KCL at B, this is IL, this is IC, this is IR. Okay, so if I want to write down KCL at B, IL is equal to IC plus IR. What is IL? Okay, so IL is, what is IC? Given by dVc by dt plus, what is IR? V0 divided by RL. V0 divided by RL. Okay, again we know that Vc equal to V0, so IL is equal to C dVc by dt plus Vc by Rn. Vc by Rn. This is equation 2. This is equation 2. Okay. So equation 1 implies the equation. I want to take this one side. Okay. So it will be L dIL by dt is equal to, let us see, Vi minus Vc minus RIL. So minus RIL, okay, minus RIL minus Vc plus Vi, minus Vc plus Vi. Okay, so DIL by dt is equal to minus R by L IL minus 1 by L Vc plus Vi by L. Okay, plus Vi by L. Okay, DIL by dt is equal to minus R by L IL plus 1 by L oh sorry, this is minus 1 by L Vc plus 1 by L Vi. Remember this equation. Okay, so equation 2, I will take this left hand side. C dVc by dt is equal to IL minus Vc by RL. Okay, so dVc by dt is equal to 1 by CIL minus 1 by CRL into Vc. This is equation 2. Suppose 3, oh sorry, 4. What will be equation 3? This is equation 3. Let us write down again. DIL by dt is equal to minus R by L IL So some system hang on. Okay. Okay, so sorry about that. So what was our system? Okay, so I will write down equation 3 and equation 4. Okay, so our equation 1 rather was RIL plus LDIL by dt plus VC is equal to VI. Okay, and IL was equal to C dVC by dt plus VC by RL. VC by RL. These are the equations. So one implies DIL by dt is equal to DIL by dt minus R by LIL. Okay, minus 1 by LVC plus 1 by L Vi. This is equation 3. 2 implies dVc by dt is equal to 1 by CIL, okay, minus Vc upon CRL. Okay, so I can put this in form of IL, Vc and Vi. What is Vi? Input. IL, inductor current. I will say it is state variable, internal state variable. Vc, capacitor voltage. Capacitor voltage. This is also state variable. Okay. So what I will do is I will write down in matrix form derivative of state variable d IL by dt dVc by dt derivative is equal to, okay, these are state variables. Okay, so I will write down state matrix and then state variable matrix IL Vc, and then input matrix. Input is only in equation 3 plus some matrix, then input matrix. This is Vi. Okay, IL terms in first equation is minus R by L, Vc term in first equation is minus 1 by L, Vi term in one equation is 1 by L. IL term in second equation is equation 4 is 1 by C. In equation 4, Vc term is minus 1 upon RL C. Minus 1 upon RL into C. Okay. Let us see what is Vc upon RL okay. In last term, there is no input term here in equation 4, so 0. This is also 0. No input term. Okay. So this is nothing but a state equation. This is IL dot This is VC dot is equal to minus R by L minus 1 by L 1 by C minus 1 upon IL plus 1 by L0. Simple, I will write down. Yeah. Okay, so this is the state equation. This state equation is which equation? This is state equation. What about output equation? See the figure, sorry. The figure told you that output voltage is equal to VC, one of the state variable. So output equation will be equal to state variable matrix is I into IL and VC. So this is output equation V equal to VC. V equal to VC. V equal to VC. What is output? Y equal to VC. When this will be the case, 0 into IL is 0, 1 into VC is 1. So 0 plus VC is VC. 0 into IL is 0, 0 into VC is 0. So Y equal to VC is this matrix. So this is output equation. Output equation. Okay. So this is state equation and output equation. In this way you can find out the state and output equation. Okay. So what is state model? What is state model? State equation plus output equation is completely termed as state model. Termed as state model. Okay. So this is termed as state model. Okay. Now we'll come to next topic, that is state space representation. State space representation. This equal to SS A comma B comma C comma D. This is MATLAB command. Okay. SS is state space. Okay. So this creates a system defined as dx is equal to a of xt plus b of ut. Only changes, it is now with respect to time. cxt plus dut. Okay, so I will write down syntax and description. Okay, SS creates empty state space object. System SS ABCD SS ABCD creates continuous time state space object. Creates continuous time state time state space object. System SS ABCDTS creates discrete time model with sample time yes. SS is equal to SSD is equal to specifies a static gain matrix equivalent to system is equal to SS in bracket empty 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 B empty and then B. Okay, so these are state space model. So you will find that there are two conversions. Two conversions. A comma B comma C comma D is equal to transfer function to state space N comma D. Okay, where N is input row vector and D is equal to numerator, sorry, N equal to input row vectors of numerator, input row vectors of denominator. Okay, this is first command. Let us see second command. N comma D is equal to state space to transfer function A comma B comma C comma D. This was transfer function to state space. This is state space to transfer function. Okay. There is third command nd is equal to ss to transfer function a comma b comma c comma d comma 1. Okay, this is for one input. Next command n comma d to transfer function a comma b comma c comma d comma k, where k is equal to kth input or kth input. Okay, in this way you can define the system. Okay, now let us take one example. Okay, state space model is given by x dot is equal to 101 minus 1, this is x, plus 01, this is u, and y is equal to 1 space x plus 0 u. Okay, so here to obtain MATLAB representation. MATLAB representation. Okay, so again we will check what is this matrix. A matrix, this is B matrix, this is C matrix, this is D matrix. Okay, so A is equal to 100 minus 1, B is equal to 01, C is equal to 11, and D is equal to 0. D is equal to 0. Okay, so how I will write down program clear all CLC A is equal to 1 space 0 1 space minus 1, B is equal to 0 space 1, sorry, 0 semicolon 1, C is equal to 1 space 1, D is equal to 0 0. Okay, then I will write down system is equal to state space A comma B comma C. Okay, let us see, we'll consider a hands-on session on this. A is equal to 1 0 1 minus 1, 1 0 1 minus 1. B is equal to 0 semicolon 1. C is equal to 1 space 1. D is equal to 0. D is equal to 0. Okay. D is equal to 0. So I will say sys is equal to state space A comma B comma C comma D. Okay, you can see the variables in workspace also. You can see the variables here. Okay, so let us move on to another example. Let us move on to another example. Here to obtain state space model of control system, state space model of control system. Okay, having transfer function Cs upon Rs is equal to S plus 5 upon S cube plus 5s square plus 10s plus 15. 10s plus 15. Okay. Okay. So this is, you can see the program. Okay, so how to write down the program we'll see. Okay, so transfer function is there. Numerator term is equal to 1 space 5. Denominator term is equal to s cube is 1, s square coefficient is 5, s coefficient is 10, constant term is 15. Okay, then I will write down a comma b comma c comma d is equal to transfer function to steady state n comma d, n comma d. Okay, okay, let us do this hands on. N equal to 1 space 5, I'm sorry, another one space. N equal to 1 space 5, d equal to 1 space 5 space 10 space 15. Okay, then a comma b comma c comma d equal to transfer function to steady state n comma d. N comma d. So you can find these values. Okay, you can see the A matrix, B matrix, okay, C matrix and D matrix and D matrix. Okay, now let us come to another example. Example 3, I will say. Obtain transfer function of following control system. X1 dot x2 dot is equal to 2 0 minus 3 5, sorry, minus 5, x1 x2, these are the states, 2 5, this is input, y is equal to 1 1, x1 x2. Okay, so how to do it, what is the program, is in next page. What is the program? Clear all, CLC. Okay, A matrix, you can write down 2 0 minus 3 minus 5. B matrix is equal to 2 semicolon 5. C matrix is equal to 1 space 1. D matrix is equal to 0. Okay, then you can write down n comma d is equal to steady state space to transfer function a comma b comma c comma d. After that, write down parenthesis is equal, sorry, parenthesis n comma d. Okay, let us do hands on. Okay, a is equal to 2 space 0 minus 3 space minus 5. B is equal to 2 semicolon 5. C is equal to 1 space 1. D is equal to 0. Okay, n comma d, n sorry, n comma d is equal to state space to transfer function a comma b comma c comma d. Okay, so this is like this. Parenthesis n comma d. Okay, so let it be CLC. Okay, so in this way you can get the example. You can get the example. Okay, let us check one more example, last example for today. Okay, circuit is given plus minus V1. This is R1, L1, C, L2, R2 plus minus V2 plus minus V2. Okay, so this is equal to A. part B, this is C, D, this is E. Okay, what is given that R1 equal to 5, R2 equal to 10 ohms, L1 is equal to 0.1 Henry, L2 is equal to 0.2 Henry, C is equal to 100 microfarad. Hundred microfarad. Okay, you need to determine state space model. Be very careful. See, you have to write down the equations. This is current I1, this is current I2, this current is I1 minus I2, this current is I1 minus I2. Okay, loop 1, loop 2, KVL to loop 1, KVL to loop 1. V minus R1 I1 minus L1 di1 by dt. Okay, minus 1 by C integral I1 minus I2 dt equal to 0. KVL to loop 2 gives minus 1 by C integral, so this will be plus 1 by C integral I1 minus I2 dt minus L2 di2 by dt minus R2 I2 is equal to V2. Okay, so I will say first loop implies V, or rather implies R1 I1 plus L1 di1 by dt plus Vc is equal to V1. Okay, therefore di1 by dt is equal to di1 by dt is equal to minus R1 by L1 into I1 minus 1 by R1 into Vc plus V1 by R1. Oh, sorry. This is not R1. Let us recheck this. di1 by dt is equals to minus R1 by L1 I1 minus 1 by L1 Vc. This is V1 by L1. Okay. So Equation 2 gives 1 by C, VC minus R2 I2 minus L2 di2 by dt is equal to V2. Therefore, di2 by dt is equal to minus R2 by L2. Okay, minus R2 by L2 minus, this will be plus VC 1 by L2 into VC, okay, minus 1 by L2 into V2, okay. So this is equation number 4. This is 3, 4 and 3. This is I2. Okay. So here there are two inductors, one capacitor. Current through one inductor is I1. Current through other inductor is I2. Voltage across one capacitor is VC. So these three are state variables. Okay. So one current, second current, and then there is a third equation that is for VC. Okay. Consider this branch. This current was I1, this current was I2. So this current is I1 minus I2. This is equal to VC. Okay, this is equal to VC. So I1, this is C, minus I2, that is capacitor current, is equal to C dVC by dt. Remember, there are three state variables. So we need derivative of each. Derivative of I1, I2 are in equation 3 and 4. We need derivative of VC. So from here, dVC by dt is equal to 1 by C I1 minus 1 by C I2. Equation number 5. 6. Okay. See now equation 3, equation 4, equation number, this is 5, this is 6. So 3, 4, 6 are the equations. 3, 4, 6 are the equations. Okay. So let us write down state model. From 3, 4, 6, di1 by dt, di2 by dt, dvc by dt is equal to three state variable I1, I2, VC plus there are two inputs. What are two inputs? V1 V2, V1, V2. What about third equation? Naturally it will be 0. Naturally it will be 0. Let us check this. Let us erase this first. Okay. V1, V2, 0. Let us check the I1 coefficient in equation 3. Minus R1 by L1. Minus R1 by L1. Let us see I2 coefficient in equation 3. There is no I2 term, so 0. Let us see VC term in equation 3. Minus 1 by L1. Minus 1 by L1. Okay. Let us say equation 4. Minus R2. I1 term is no I1 term. No I1 term. So 0. What about I2 term? Minus R2 by L2. Minus R2 by L2. This is I2 term. What about VC term? VC term in equation number 4, there is 1 by L2. 1 by L2. Okay. So this is equation number 4. So here remember that this will be to imply. This is minus 1 by L2, sorry. Minus 1 by L2. So minus 1. Equation number 5. There is 1 by C term for I1. Minus 1 by C term for I2. Okay. And no term for VC. No term for VC. 1 by C minus 1 by C, 0. Equation 4, equation 3, input voltage is having one term 1 by L1. That is multiplied by 1 by L1. V2 term, equation number 4, minus 1 by L2. Minus 1 by L2. Okay. This term is 0. So what will be size of this? See here. This is 3 by 1. 3 by 3. Naturally this is 3 by 1. So whatever matrix I want from multiplication of this is 3 by 1. So 3 by 1 is this matrix. Okay. This matrix will be 3 by 3. Isn't it? This matrix will be, this is 3 by 1. Therefore this matrix will be 3 by 3. This is 3 by 1. Okay, so 3 by 3 cancels. So we will obtain 3 by 3. So what I will do is I will write down this matrix here only. Okay. Okay. So plus 3 by 3 matrix. One input, second input, 0. For third equation, see third equation. V1 is 1 by L2. 1 by L1, sorry. There is no V2 term, there is no VC term. Okay. Fourth equation, see here, minus 1 by L2 is V2 term only, no V1 term, minus 1 by L2. See, check whether this is correct or wrong. Okay, so this is 0. Third matrix, no, there is no input here at all. So 0 V1, 0 V2, 0 third input. Okay, so in this way you can find out the answer. Output. What is the output of this? We want I1 as the output, I2 as the output, VC as the output. So we want three outputs. So three outputs will be I1, I2, VC. Rather three states. Okay. So this is X matrix. C matrix will be what? Output Y1, Y2, Y3. These are the outputs and states. So let us see. First entry is only I1, next is 0. Second entry is only I2, next is 0. Third entry is only VC. So this is C matrix. Okay. So we will calculate A matrix. What is A matrix? What is A matrix? See here. Minus R1 by L1. So suppose this matrix is nothing but A1. This matrix is A2. This is A3, A4, A5, A6. A5, A6. Let us see in the program. A1, 0, A2, 0, A3, A4, A5, A6, 0. B matrix. This is B matrix. B1, B2. So B1, B2, B1, B2. See here, where is B1 and B2? So B matrix is B1 0 0 0 B2 0 0 0 0. Finish. C matrix. C matrix is simple. 1 0 0 0 1 0 0 0 1. What is D matrix? 0 0 0 0 1 0 0 0 1. What is D matrix? 0 0. What should be size of D matrix? This is 3 by 1, 3 by 3, 3 by 1, plus D matrix is how many inputs are there? V1 V2 0. So this is 3 by 3. 0 0 0 0 0 0 0 0. This is 1 2 1 2 D matrix. Okay, so let us write the program hands on. Let us write the program. Okay, let us see new script file. R1 is equal to 5, R1 equal to 5, R2 equal to 10. Okay, L1 equal to 0.1, L2 equal to 0.2, C is equal to 100 microfarad, that means 100 into 10 to the power minus 6, 100 E minus 0.6. Okay, now we want to write down the values of A, B, C, D. A, B, C, D. Small a, that means content of A matrix. So A matrix components. Okay, so A1 equal to minus of R1 slash L1. A2 is equal to minus of 1 slash L2. A3 is equal to minus of R2 slash L2. A4 equal to A4 is A4 A4 equal to minus of 1 divided by L2. Okay, A5 equal to 1 slash C. A6 equal to minus 1 slash C. Okay, then B1 is equal to see what is B1. 1 by L1, B2 is minus 1 by L2. 1 slash L1 B2 is equal to minus 1 slash L2. Okay, finish. C you know, D you know. Okay, no need to write down components. So now A matrix A is equal to A1 space 0 space A2 semicolon 0 space A3 space A4 semicolon A5 space A6 space 0. B equal to B1 space 0. Let us see once again size of B matrix 3 by 3 0 0. Okay, 0 0, then 0 B2 0, sorry, 0 0 0. Okay, C matrix is equal to 1 space 0 space 0 0 space 1 space 0, then 0 space 0 space 1, 0 space 0 space 1. Okay, D matrix is equal to 0 space 0 space 0 0 space 0 space 0 0 space 0 space 0. This is D matrix. D matrix. Okay, so what I want is to develop the state model. Okay, develop the state model. So I will save this in Unacademy folder. Okay, state space RLC. Okay, take this to Unacademy folder. Fine. Now I will say SSRLC. Okay, in this way you can define. Okay, A B C D. A B C D. Fine. So you can also write down transfer function. So let us see. input 1 transfer function. What is input 1? n1 comma d1 is equal to state space 2 transfer function in bracket a comma b comma c comma d comma 1 for first input. Okay, percentage input 2 transfer function. Okay, I will say n2 comma d2 is equal to state space 2 transfer function a comma b comma c comma d comma 2 comma 2. Okay, then print sys n1 comma d1, print sys n2 comma d2, n2 comma d2. Okay, we'll save this and we'll run this. Okay, in this way you can find out transfer function. Fine. So we'll conclude this part today itself. Okay. So let us go to our slides. Okay. Thank you very much. I will wrap it up for today. So how to unlock free plan on Academy? Just go to Unacademy Learning app, install it in your mobile. Okay. Go to daily interactive live classes, go to GATE ESE, again GATE and ESE, go to plus subscription. Okay. So you can find out whatever video you want to, videos or the course you want to watch it for free on steps 5. Click on that, you will be asked to enter the invite code. Okay, enter the invite code SSM10 from here. Okay, then press unlock. Whenever you press unlock, this content will be unlocked for free viewing. Okay, so this is how you free stuff on Unacademy. Okay, so let's crack GATE and ESE, guys. Okay, comment, subscribe and like, okay, on our videos. Use my code SSM10, hit the bell icon for further notification. We got Telegram group also. Okay, join that group and you will get updates on upcoming videos in that group also. Okay, so thank you very much. Thanks a lot. So I will say goodbye. Okay, so not goodbye. See you for tomorrow. Okay.